Good morning, all of you. This is Dr. Nageshwar, working as Associate Professor in the Department of Electronics and Instrumentation. I am here to deal the subject Analytical Instrumentation. Today we are going to see about the block diagram of Analytical Instrumentation and examples of each and every block. So, what is Analytical Instrumentation? Analytical Instrumentation is a science Analytical instrumentation is a science which deals with the analysis of samples, chemicals, etc. It also deals with the identification of atoms. It also deals with the separation of chemicals. It also deals with the identification of the particles. So, if you see the block diagram of an analytical instrumentation, it basically consists of 4 blocks. The first block here indicates chemical information source. The second block is a sensor. And the third block is signal conditioning unit. And the fourth block is display unit. So these are the 4 important blocks of an analytical instrumentation. So what is an chemical information source? So chemical information source is nothing but it gives an information about the source whatever we are using. So examples, we say that sodium is an element which emits yellow radiation. So here the sodium acts as an chemical information source. So that is sodium is a chemical which has a property of emitting yellow radiations. So this is what do you mean by chemical information source. Next, the second important block of an analytical instrumentation is sensors. So what do you mean by sensor? Sensor is a device which senses the signal. So sensor is a device which senses the signal. Sometimes you can also call a sensor as a transducer. So before that, what is a transducer? Transducer is nothing but which converts one form of signal to the other form. That is, if you give an input as a non-electrical quantity, it gives you output as electrical quantity. So sometimes sensor can be also called as an sensor can be also called as an transducer. Here we are taking example sensor as piezoelectric crystal. So this crystal which gives output as voltage, and if you give input as some force, pressure, etc. Here this input acts as an non-electrical quantity. And here the output acts as an electrical quantity. So this is what do you mean by sensor or a transducer. Not all sensors are called as a transducers. Not all transducers called as a sensors. There are a little bit difference. This is the second part of an analytical instrumentation. And the third part is, or the third block is signal conditioning unit. So what is signal conditioning unit? Signal conditioning unit is nothing but you are conditioning the signal in such a way that it should be able to see in the form of an usable or user friendly format. So we can do any sort of actions. So here the signal, whatever you are getting it from the sensor, is not exactly it in the usable format, or you cannot directly say what is an output or exam. So example, if you see here, if you see RTD, which is an resistance temperature detector, here this is used to measure the temperature. Here the temperature is an input which is able to measure by using your RTD, and the RTD gives you output in the form of change in resistance. Here degrees is being converted into your ohms, that is resistance. So here we cannot directly get the output in the form of a degrees. You want to measure the temperature, we'll keep an RTD, you get the output in the form of a resistance. But by seeing the resistance, you cannot say what is temperature. For that purpose, we have to convert this ohms into degrees Celsius. How is it possible? This is possible by using your signal conditioning unit. Here in the signal conditioning unit, you have amplifiers, filters, etc. All these things will you have analog to digital converter, digital to analog converters, etc. So all these are the part of your signal conditioning unit, which converts this ohms, that is resistance, into user friendly format into degrees Celsius. So this Celsius, whatever you are getting here, is sent for the display, which is an fourth block of the system. So here the display indicates which can be used to display. So that is, it may be in the form of analog or it may be in the form of digital. So if you're talking about an analog, you have PMMC, permanent magnet moving coil meters. You have LCD, LED, etc. So whatever the output you are getting from the third block, that is from the signal conditioning unit, that will be displayed here in the display part. So the display, whatever the output you are getting, it should be in the form of, okay, or it should be it should be in such a way that these systems should be able to take it and give the output. So that is the main important task of your display. So here, whenever you're talking about all these four blocks, the first two blocks are called as a characteristic module, and second two blocks are called as a processing module. So what is that characteristic module and processing module? So in the first two blocks, we are getting the output, okay, which gives you the information saying that it is so and so. Or example, here the sodium is giving you LO radiations, where the sensor can sense those LO radiation. So you are getting an output which now you can see here. Here, if you take here RTD or piezoelectric crystal, so you are giving an input as a pressure or a force, you are getting the output in the form of an voltage. So this voltage, whatever you are getting, it's nothing but the characteristic. That is, the pressure or force is being represented in the form of an voltage. So this is the characteristics. And coming for the second block, which is processing module. So these characteristic module are processed, and then we are sending it to the processing, because the raw signal whatever, or the raw output whatever you're getting, is not an user friendly format. For that, we are processing it, such as amplification, filtration, A to D converter, D to A converter, etc. So all these things are called as an processing module, hence the name processing module. So these are the four important blocks of your analytical instrumentation. So whatever we are seeing here, see, this is an example. So analytical instrumentation is a study of the separation, identification, quantification of the chemical components of natural and artificial materials. So the main important elements of this AI are information source, sensor or transducer, signal conditioning unit, and display unit. The first two are called as a characteristic, and the second two are called as a processing modules. Now, if you see for the block diagram, whatever we have seen, so this is example as characteristics. So you are sending the light radiation, okay, sending it to the sample, where the sample is absorbing the radiation and giving the output. And here this is called as an characteristic module, and this part is called as an processing module. Here, whatever the output you are getting from this sample, that is processed by using amplifying analog to digital converter and digital, and that is being seen in the readout. That is, it may be in the form of an analog value, or it may be in the form of a digital, that is meter, plotter, or computer. Now, if you see any of the block diagrams of an analytical instrumentation, it is completely based upon your electromagnetic spectrum. What is an electromagnetic spectrum? Electromagnetic spectrum is nothing but which comprises of all different types of wavelengths or radiations. So if you see here in this electromagnetic spectrum, we have different types of radiations, such as ultraviolet, infrared, X-rays, visible, gamma rays, and radio waves, alpha, beta, gamma radiations, etc. All these are the waves which are a part of your electromagnetic spectrum or electromagnetic radiation. What of the wavelengths we are seeing basically comes under visible radiations. If you're talking in terms of wavelength, 380 to 760 nanometers are called as in visible radiations. Less than 380 nanometer wavelength are nothing but ultraviolet. And these ultraviolet, again you have near ultraviolet, far ultraviolet, and greater than 760 nanometer wavelength are called as an infrared. And here again in the infrared you have near infrared, far infrared. Next to the infrared radiations you have microwaves, then you have radio waves, then you have alpha, beta, and whereas coming for this lesser than UV, you have X-rays, gamma rays, etc. So this complete spectrum is called as an electromagnetic spectrum. The applications of AI in the real world are so many. So in this real world scenarios, we are wide varieties of analytical instrumentation applications, such as pharmaceutical industries, biotechnology, microbiology, environmental laboratory automations, etc. So not only in the pharmaceutical industry, we have for identification of what you can say DNA, identification of pathology labs, etc. So if you see for a pharmaceutical industry, it is used to identify the chemicals, compounds, their properties in the drug discoveries, and it's also used in the quality assurance clinical studies. and it is also used in the biotechnology for identification of proteomics and genomics. And at the same time, it is also used in identifying of microbiology, that is the main important critical application of analytical, that is food safety and rapid microbiology. And coming for the other applications such as environmental applications such as pollution control, pesticides, residues, etc. And it is also used in the chemical analysis such as for identification of samples, and at the same time it is also used in the automation such as for sample preparation, etc. So and sorry, so these are the applications of an analytical instrumentation which are generally or commonly used in most of the industries. So thank you all. This is for today's class. In the next class we see about the different types of spectrophotometers, etc. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.